Welcome to the next part of trigonometry in National 5. This one gets us really to deal with non-right angled triangles, and we'll do it in three parts where we're looking at finding the area of a non-right angled triangle and then using two new formulas called the sine rule and the cosine rule. Now, the first thing, before we look at any of these, first thing we need to do is look at how we're now going to name our triangles, because these formulas are really going to be naming sides and their related angles. So we just need to have a way of doing this. And the easiest way to name a triangle is, first of all, we start by naming the vertices, i.e. where the angles are, and then the side opposite the angle is just going to be the small letter version of that angle. So here we have triangle ABC, and you'll see the opposite angle A, we have side A with the small a, opposite angle B we have side B, and opposite angle C we have side C. Okay? Now, as I've said to you many times before, we won't always use the letters A, B, and C. Okay, some examples will have, look at triangle DEF, and apply either the area formula, the sine rule, or the cosine rule. So the first thing that you need to do before you even look at that is name your triangle correctly, so you know what side you're talking about, because the order in which you use the sides is really going to determine how your formula works out. So in this case, opposite angle D would be small letter D, opposite angle E would be small letter E, and opposite angle F would be small letter F, etc. Okay? So that's just a quick intro into how we're now going to name the triangles. So it's assumed that all trig knowledge that you have until now has been remembered. Okay, so for this we're going to use our knowledge really of solving trig equations, especially when it comes to finding out the sizes of angles. Okay, so everything you know about trig just now still has to come into play. So first thing we're going to do in this topic is look at the area of a triangle. Okay, so up until now you've only ever dealt with area of a triangle when it's been a right angled triangle, or if it's been a triangle where you have known the base and the perpendicular height. Okay, so by that I mean you have always had a height of a triangle, we'll call it H, and we've had a base of a triangle, we'll call it B. And obviously you've known it's half of the surrounding rectangle, so it's going to be a half base times height. But now we're not always going to know what the perpendicular height is. This time all we know is the sides of the triangle and then the angle in between those sides. Because when you have a triangle, if I have a length of a triangle, let's say that that is going to be a certain length, let's just say it's 5 centimeters, and then at a certain angle I then draw a line which is 4 centimeters, that will then give me the length of another side. But when that other side encompasses the entire triangle, the angle that we have here, we'll just call it angle X, that is all we need to determine the actual area. So this is where we get this formula here. Area is equal to a half AB sine C. This is one of the formulas that is always given for you in any examination that you do. So there isn't a need to learn it, but you have to know when to apply it. And all this formula is really getting us to know is, well, to find the area, it's just going to be a half of two sides, but then we're going to multiply the sine of the angle in between those two sides. So if I was to look at this triangle here, let me just rub that out. If I was to look at this triangle here, if I've got area is equal to a half AB sine C, let me have a look and name my sides. So if this is angle A, this will be small side A over here. If this is angle B, this will be small letter B, I really should say. And if this is angle C, this will be small letter C over here. Okay, so this formula is talking about half AB sine C. So it's a half multiplied by this side, times this side, and then we're multiplying it by the sine of the angle in here. So to make this formula work, what we really need is this situation here where we have a side, and the angle in between. So we're always looking out for this kind of situation. Now, it doesn't matter the fact that, say I wanted to work out the area and I knew what, if I knew what A and C were, I would just have to make sure that I knew what this angle was up here at B in order to work that out. Okay? And in that situation, all I would do is I would just change my letters in my formula to make it fit. Okay? So let's have a look at example 1 then. So example 1, it says, find the area of each triangle. So the first one is we've got an equilateral triangle. So you'll remember from an equilateral triangle, all three sides are the same size. And they've all got side 4 centimetres. So this is 4 centimetres, this is 4 centimetres, and this is 4 centimetres. So this is, we'll call that A, we'll call that B, we'll call that C. So let's go ahead and name the sides then. Okay, so this will be side A, this will be side B, and this will be side C. So my formula is area is equal to a half AB sine C. As I said, it'll be in the formula sheet. You don't need to remember it off by heart. You'll probably find that you will remember it because you'll be using it quite a lot. So area is equal to a half AB sine C. So let's look at what we need here. Well, we need the length of side A. That's going to be 4 centimetres. We need the length of side B, which is 4 centimetres. And we also need the sine of the angle in between A and B. Now, thankfully, we do know this because it's an equilateral triangle. So if we have 3 equal sides, it means that we have 3 equal angles. So 180 divided by 3, that will give us 60 degrees. So then I'm just going to go ahead and put this into my formula. So that's going to be a half times 4 times 4 times the sine of the angle in between, which is going to be sine 60. And then all I need to do is go to my calculator and work that out. Now you'll remember back when we started doing trig all those many months ago, you'll remember that I always called out, make sure your calculator is in degrees mode. So it's back to that. You must make sure that your calculator has got a D or a DEG at the top to make this work. Okay, so it's going to be a half multiplied by 4, multiplied by 4, multiplied by the sine of 60. And that will give me 6.92820323, which will be approximately 6.93 square centimetres to 2 decimal places. Okay. Next one, we want to find the area of this triangle. So we've got triangle ABC, and we have 2 angles, and we have 2 sides. Now remember what we need for this. To make the formula work, we need 2 sides, and then the angle in between the 2 sides. We want this situation here. Example B. Looking at this triangle, triangle ABC, you'll see that I have sides 7.2 metres, 4.6 metres, and I also have 2 angles, 43 degrees and 70 degrees. So I want to work out the area of the triangle, but you'll have to notice here that we don't have what the conditions we need to work out the area. We don't know 2 sides and the angle in between those 2 sides. So for this to work out, I need to know this angle up here. Remember, I need this situation here, where I have 2 sides and the angle in between. Now, in maths, especially in trigonometry, a lot of questions will be given in such a way that you have to put in your own little bit of knowledge before you then go and solve the equation or solve the problem. So what we need to know here is that we need to know the size of this angle up here. So before I even think about doing it, I want to find out the size of that angle. So add them up. So we're going to say 43 plus 70, which will give me 113. So then it'll be 180, take away 113, which is 67 degrees. And now I have the conditions for the area formula. I have the sides, I have the side, and I have the included angle. I can now go and make it work. So the formula says area is equal to a half AB sine C. Now, we're not dealing with those letters, so let's label our triangle just now. So this will be small letter A, this will be small letter B, and this will be small letter C. So what we really have here is area is equal to a half AC sine B. Because I'm dealing with side A, side C, and the included angle is B. Now I can put my values in. So that's going to give me a half times 7.2 times 4.6 times the sine of 67 degrees. And then go to your calculators. Remember, make sure your calculator is in degrees mode. So half times 7.2 times 4.6 times sine 67, and we get 15.24. So that'll be 15.24 356 037, which will give us approximately 15.24 meters squared, and that's to 2 decimal places. Now, I didn't have to put this line in where I changed the letters round. The more you do this, the more you will get fine with just seeing the situation and plugging the numbers in. So don't feel that you have to take that extra line and change the letters round to make the formula work. If it helps you, by all means do it, but you are absolutely fine to go from this line to that line. Okay?